Uh, Wireshark is a network analyzer which captures the packet I think, to analyze the packets and all.
Yeah. So the main purpose of Wireshark is to capture the packet and to
Mm-hmm.
analyze it. So Wireshark is an open source. Open source
Mm-hmm.
means we can use Wireshark for free. And secondly, the source code of Wireshark is officially available at this website, which means we can contribute in the Wireshark source code. Let's say you wanted to add any new feature, then you can simply. So that is like Wireshark is open source. We can contribute in the Wireshark and then we can also use it for free. Then we have cross-platform, which is we can use Wireshark on Windows, Linux, and macOS. Then it is mainly used for capturing the packets and analyze the traffic. So what kind of packets the Wireshark can capture? So Wireshark can capture the packets which are coming to and from your interface where you are capturing. And secondly, Wireshark can capture the multicast and broadcast packets. So these are the packets Wireshark can capture. For example, let's say the Wireshark is running in my local machine. So the Wireshark can capture the packets which is coming to and from my interface, which is in my local machine, and the multicast and broadcast packet. So these are the packets captured by the Wireshark. Let's say you have installed Wireshark on any other device, like let's say firewall or any particular medium, let's say any gateway like router or switch, then the Wireshark can capture the traffic of the entire network. So it depends. Okay.
Mm-hmm.
Yeah, so it is like a most popular tool and it is used in almost every domain. Like we can use Wireshark in networking for analysis of network for troubleshooting purpose. We can use Wireshark in cybersecurity or in forensics for investigating the malwares in the traffic, or we can say the malicious traffic in the network.
Mm-hmm.
We can use Wireshark also in the application development. Let's say you are an application developer and you have implemented a protocol or any let's say any port number on your application. Now you wanted to check if that port number is working efficiently or not, or containing any error or not. Then you can use Wireshark to analyze that protocol or that port number, or like how the data is flowing from that port to the entire network. So Wireshark is like a like we can use in many domains, in the networking, in the cybersecurity, in the application development. So as I said, Wireshark is an open source. So the main source code of Wireshark is located at GitLab. So we can copy this URL. So the main source code is here. If we wanted to contribute, then we can contribute in the Wireshark source code, which means if we can add new features, we can add something new in the Wireshark, like in the official Wireshark. If you know the languages like C, C++, and Lua. So Wireshark is made up of three languages, C, C++, and Lua. And this is the official source code of Wireshark. So if you
So
want,
what was
if
the
it,
last language?
Lua, Lua,
Lua.
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 Yeah. So we have these three languages.
Okay.
Okay. So if you want, if you're interested, then you can go through the source code. Like, well, it is not compulsory.
Mm-hmm.
So Wireshark is a GUI platform, which is graphical user interface. We have one more version of Wireshark, which is CLI, and that is known as T-Shark. So T-Shark is entirely based on commands. So let's say we are capturing on any remote system, any system where GUI is not available, then we can use T-Shark for capturing the packets. So Wireshark is a GUI platform and T-Shark is a CLI. T-Shark also performs like capturing and analysis both. But in the Wireshark, we may prefer that in the Wireshark, we capture the packet and we analyze it. In the T-Shark, we can also capture, but for the analysis purpose, we prefer Wireshark. Because for the analysis purpose, T-Shark is not that much efficient because it is totally based on the commands or in the, like as a CLI interface. So for the analysis also, we prefer the Wireshark. Okay. So how we can install Wireshark? So we can simply install on Windows. So we can search for the Wireshark download. And we can visit the first URL, which is wireshark.org. And we can click on this first link. Okay. So here we can install. And let's say you are using, like you can download. The installation process is very straightforward. You can simply click on next and install. So that is like a very straightforward process of installing Wireshark. Then for installing Wireshark on the Fedora or Red Hat, if you are like running the Fedora or Red Hat based Linux system, then you can type commands like yum search Wireshark and yum install the version of the Wireshark. For the Debian based system, you can use apt-get install Wireshark. Okay, so these are the commands by which we can install Wireshark. Basically, on the Debian based system, Wireshark comes pre-installed. But still, if you want to, this is a command which is apt-get install Wireshark. Is it clear this much? Any questions?
Yeah, no, it's fine.
So now let's get familiar with the interface.
Can you get a little bit slow? I think you're too fast.
Sorry.
I don't know your pace. I think this is how you teach. I don't know, but I think like for me, you're going too fast.
Okay. Thank you for
if you can,
telling me.
yeah, if you can just go slow down, yeah,
Yeah,
that would be
sure.
great.
So now let's get familiar with the interface of Wireshark. Okay, so I will going to use Wireshark on the Linux operating system. You can use the same on Windows. The commands and we can say the way we perform or the interface of the Wireshark is same as in the Linux as in the Windows. Like they are same only. There's no difference in the Windows and in the Linux, like the interface of Wireshark. Okay, so basically in my Windows machine, the Wireshark is not working. So that is why I'm using on my Linux. Okay, but the operations, the options, everything is same. Okay, so this is the first window of Wireshark. And here we have some various options. First option is this one. So here contains the list of all the recent files which I have opened. Okay, so we have this file path and file name here and then size of the file. Then we have this capture filter here. Okay, here we can apply the capture filter. Now, what is capture filter? We will discuss that later. So here we can apply the capture filter. And then here we have the list of all the interfaces where we can capture the packets. So let's say we have this interface is ETS0. And here, just give me a second.
Yeah.
Yeah. So here we have this list of all the, just a sec. Yeah. So here we have this list of all the interfaces. And here you can see some lines here, which means there's some traffic going on these interfaces. Okay. So here this is important. Like here we can select one interface or we can select multiple interfaces. That is our choice. Okay. Let's say I'm selecting on the first interface. So here I can click on double click to select the interface. Okay. So when you select, the capturing has been started. Okay, now let's talk about the interface of Wireshark. In the first window, we will see these options. So first we have this packet list. In this, we have all the list of the packets. Then we have packet details, which contains the details of the packets, like packet by packet details, and it contains layer by layer details. Like first we have the physical layer. So we have this physical layer detail. Then we have this data link layer detail and so on. And then we have this packet bytes details. Okay, so when you open the Wireshark, you will see these three windows. First contain the packet list, second contains the packet details, and third contains the packet bytes. Apart from these three windows, we have these like options. First, we have this menu bar, then we have this main toolbar, filter toolbar, packet list, packet details, packet bytes, packet diagram, and the status bar. Okay, so let's see one by one. First, we have menu. So in the menu, we have file, edit, view, go capture, these options. Okay. So let's discuss one by one. So here, this is, we have menu bar. Okay. So in the menu bar, we have options like file. Okay, so at first we will just get familiar with the interface, like we will see which options are there in the Wireshark. And the detailing of these options we will go later on. Okay, so first we have file. In the file, we can open file, we can close any file, we can merge files, we can export packets from one file to another. Okay, we can export objects like, for example, let's say we have, let's say we have some PDF or some kind of files in the traffic, in the packets. So we can export those files into the local machine. So that is export objects. Same as we can print something, we can quit the Wireshark. So we have these options. Then we've edit. In the edit, we can copy. We can find any packet. Now, how we can find packet? We can find packet on the basis of strings. Like we can find packets on the basis of some alphabets. Like let's say you are finding some username or password in the entire packets. So you can search for that particular username or password. Okay, so we will see this later in detail. We can find next, find previous packet. We can mark any packet if that is important. We can mark all displayed and so on. We can ignore packets also, but that is not useful for now. Okay. Then we have preferences option in this particular Wireshark, in this option. So preferences is take you to the settings of the Wireshark. Okay. So that we will see later. Like each and every option we will see later on. Then we have view. We can view packet. Like view is like we can just make changes in the interface of Wireshark. For example, here we have this packet details. In this packet details, let's say I just don't want to see this packet detail. So I will click on view and I can untick that option, which is packet detail. Now you can see packet details has been disappeared. Same as I can untick any of the option, like I can remove main toolbar, I can remove the filter, I can remove the wireless toolbar and so on. There are like many options. So I can also remove the packet list. Same in the view option, we have time display format, which is very important for us. So with the help of time, we will go to analyze the packet delays. Okay, now here we have various times, which we will discuss later. Okay, then we have name resolution. Name resolution is like we are converting the IP addresses into name. Like we are giving a name here. For example, here you can see we have a name here, which is this one, Kali. So this is my Kali machine. So this is the name here. Same as we have this Earth. So this is my router name. So with the help of name resolution, we are having the names here. Like instead of the IP address, we are having names here. Okay, then we will see later how we can enable and how we can disable it. Then we have this zoom in, zoom out. We can resize the packets. We can expand the trees. That we will see later. And here we have this coloring rules. Now here you can see the colors of the packets here. We have green color for the UDP. We have this yellow color. I think this is for the ERP packets. And we have these colors. So coloring defines us like how many, like which packets are of which particular protocol. For example, green packets are of UDP. How do I know? You can simply click on view and there's an option of coloring rules. So from the coloring rules, you can check out which packets are of which color. Even you can change the color, you can export the color. For example, for the ERP, we have this orange color. For the ICMP, we have pink color. For the HTTP, we have light green color. For the UDP, we have this grass green color. Let's say I just wanted to change the color. So we have two colors here, foreground and background. So I can click on background. So you can pick up any color from the list. Okay. So let's say the blue color. Now blue color will goes to the UDP here. Okay. So now you can see the packets, the green color packets turn to blue, which is it is like a UDP packets. Then we have this reset layout. We can reset the layout. We can resize columns. So these are not important because we can resize columns from here also. Like if you want to resize, we can resize from here also. So that is not important. Then we can go to any packet. We can go to next packet or previous packet, which means we can scroll down or we can use upper key or arrow like down key of the keyboard. We can go to the first packet. We can go to the last packet and then we can go to the next packet in the conversation and so on. Like we have many options. And here we have this auto scroll. Auto scroll is like it will keep on scrolling if the packet is capturing, if the Wireshark is capturing the packet, which is it is in the live capture, and the packet will keep on scrolling down until we press the stop button. So it is a feature of auto scroll. Then we have capture. So in the capture options, this is the option here. In this particular window, we can like changes the interface. We can remove any interface. We can add any interface. Also, we can automate Wireshark. How we can automate? For example, let's say you wanted to capture the packets for 1 hour only. So you can automate Wireshark. You can like set a timer that Wireshark can capture the packets for 1 hour, and after 1 hour, it will automatically stop. So it is like you can automate Wireshark on the basis of packets, okay, like number of packets, on the basis of packet size, and on the basis of packet, like how much you wanted to capture, okay, or for what time you wanted to capture. So that we will see in the this options here. Then next we have this capture. In this we can start, stop, and restart. And here we have this capture filters, which we will discuss later. Okay, then we have this refresh interfaces. Then we have this analyze. In the analyze, we have display filters. Now this window and this window, which is statistics, these are mainly for the analysis purpose. Like let's say you wanted to analyze the packets on the Wireshark, then we can use this statistics and analyze option. In the statistics, for example, let's say we have this protocol hierarchy. So this protocol hierarchy will tell us about how many packets are of which protocol in the entire network or in the single Wireshark file. For example, here we have this Ethernet. Ethernet is a interface here. And then we have this IPv4. Okay, in the IPv4, we have around 88% of packets out of 100%, which is 60 packets out of 68 packets. Then we have this TCP. In the TCP, we have around 5.9 packets, and which is 4 packets are of TCP only. So protocol hierarchy will tell us how many packets are of which particular protocol. Okay. Then, same as we have many options in the statistics, we will discuss that later one by one. Like which option means what. Okay, like we have graphs here, we have flow graphs, we have conversations, and so on. That we will discuss later. Then we have telephony and wireless. In the telephony, we can capture the VoIP packets, RTP packets, and so on. Same as the wireless, we can capture the wireless packets like Bluetooth or WLAN traffic and so on. Then we have tools here. In the tools, we can check out the firewall rules here. We can check out the credentials here. And we can also use the Lua console. Okay. And here we have this help. In the help, we can open the Wireshark website. We can use that FAQs, and we can also use answer and questions of the Wireshark. We can use the manual page of the Wireshark, and also we can use Wiki, which is like the official documentation. And we have this about Wireshark, which will tell us the latest version of Wireshark. Okay, and some other information like authors. So these are the authors which contributed in the Wireshark main source code. Okay, and here we have some keyword shortcuts and some other information. Also here we have the sample captures, which we are going to use later on. Sample captures are like, let's say there's a scenario. Let's say we wanted to analyze any certain traffic, let's say VoIP traffic. Okay, like wireless audio traffic, which is VoIP. So here, let's say we don't have any scenario of capturing the packets over VoIP. So in that case, we can download the pre-existing capture file from the Wireshark so that we can analyze it for knowledge. So that we can do. Okay, so here we have the sample captures. So sample captures are very useful in the Wireshark. Okay, let me show you this. Sample captures. Wireshark. Okay, let's say I just wanted to let's say I just wanted to download TCP sample capture file. So this will take me to the TCP files. Okay, we have different types of TCP, UDP, and all sort of protocol packets file. So we can simply install these files. These are like all Wireshark file, and we can start analyzing that. Okay, so if you wanted to analyze, you can download from here also. So this is all about menu. After menu, we have this main toolbar, which contains some colorful buttons. Okay, for example, if we wanted to start capturing, we can use start. If we wanted to stop, we can stop capturing. And this is for restart. Then we have this options here. In the options, we can check out like various options, which means this is the menu, sorry, the main toolbar. Okay, from here we can start capturing, stop capturing, restart capturing, and this particular option, and this particular option from the options. This one, they are same only. Okay, they are same only. They will take you to the interface settings, or if you wanted to automate Wireshark, then you can. So it is like these are options are same. Then we have this. We can open file, we can close file, we can open file, we can save as file. Okay, like we can save any file, we can close file, we can reload file, we can find any packet. So this is very important. Let's say we wanted to find anything, so we can find on the basis of particular pattern, or we can find on the basis of particular string. Okay, strings are like combination of alphabets and numbers. So we can also find on the basis of strings or any certain pattern that we will see. Then we can go back or go forward. We can also use upper key or down key for scrolling up and down. Then go to any packet. If you wanted to go to any specific packet, which means packet number, then you can. For example, here we have various numbers here. Okay, for example, these number. Okay, let's say we have this limited number. 68 packets are there. So let's say I just wanted to move to packet number 67. So I can go. Okay, I can click on this option, which is go to packet, and I can simply go to that packet. Okay. Then this option you will find same as in the go option. So these option in the go and these options in the main toolbar, they are same only. There's no difference. Okay, then we can go to the first packet and go to the last packet. Then we have this auto scroll. We can keep on scrolling. We can turn off this auto scroll also, and we have this colorizing. We can also disable the coloring rules here. So this one, first is for the auto scroll and second is for the coloring. Let's say I just wanted to disable the colors. So I can click on this disable. So this will disable the colors of the Wireshark. So coloring is mainly for the users only. Okay. Same as we have this auto scroll. So this will keep on scrolling. So let me restart the capturing. So let's restart again. And if I enable this auto scroll, so now this is enabled. You can see this will like keep on scrolling when there's like lots of number of packets. Right now they are like very few packets. So we can generate some traffic. We can ping any website. Okay, so here you can see it is auto scrolling. Okay, so it is keep on scrolling automatically. So this is auto scroll. We can also press disable to disable the auto scroll. So this will now not auto scroll automatically. And if I click on this again, auto scroll, so this will again automatically scroll. Okay, so this is the option which we can use when we have a large number of packets in the traffic. So let me stop that. Next option we have this zoom in, zoom out, and normal size. So these are the options like we can zoom in packets, we can zoom out the packets, we can present all in the normal size, and we can resize columns. Like each column contain the same size. Okay, so this is resizing columns. So this is all about the main toolbar. Is it clear this much? Any questions?
Um, no, I'm fine. You were talking about the three windows. What are those windows like?
So now we have these windows, which is
You know, when you capture
this
the
one.
packets, yeah. This and
This is
there's like
packet list. Okay. This one is packet list where you will see the list of all the packets.
okay.
Then we have packet details, which I have disabled. So if you want to enable, so I will click on this view and there's an option of packet details. So this contains the packet details. Now this detail is of each and every packet. Okay, each packet. So, and this detail is layer by layer. For example, here we have this frame layer. Frame layer is physical layer here. Ethernet layer, it is a data link layer. IP layer, it is a network layer. And this UDP, and this one is a transport layer. And this DNS, it is an application layer. So this particular layer is following the TCP IP model. And this is showing the details layer by layer. Okay. And we can also expand to see the details. So give me a second. Okay.
Yeah, sure.
Okay. So this is packet details. Then we have third window, which is packet bytes. So when you open the Wireshark, you will see the packet bytes. Like we have two windows. We have packet bytes and we have packet diagram. For example, here, this is packet list. This is packet details. And then we have packet bytes. So either we can see the packet bytes or we have fourth window, which is packet diagram. So we have four panes here: packet list, packet details, packet bytes. So we can click on, here I have enabled the packet diagram instead of packet bytes. So packet diagram will show the diagram like a structured format of the packets, like what it contains in each and every header. In the Ethernet header, we have this details, and then it is like a diagram for the headers of the packets. Okay. Then apart from packet diagram, we can also see the packet bytes, which we have to enable. So there's option of edit in the preferences. There's an option of layout. In the layout, we have this pane number 3. In the pane number 3, instead of packet diagram, click on the packet bytes. So this will show the packet bytes instead of the packet diagram. So here we have packet bytes. So these are the main windows in the main panes in the Wireshark window. Okay, packet list, packet details, and packet bytes. Again, if you want to see the packet diagram, so we can switch. Okay. And before that, before the packet list, we have one more option, which is filters. Filter toolbar, where we can apply the display filter. Like we have two types of filter: capture filters and display filters. Okay, we will discuss what are those. But for now, we can apply the display filters here in this particular pane. Now, what are display filters? So we have two types of filters in the Wireshark. We have capture filters and then we have display filters. So let's say you wanted to capture the packets of only TCP. So in that case, we can apply the capture filter. So Wireshark, when we enable Wireshark or when we start capturing, Wireshark capture all sort of packets, like protocol packets of all protocols. So in the capture filter, if we apply capture filter, so Wireshark will only capture the packets of that particular protocol only, or of that particular condition. It can be any condition here. So capture filter we use before capturing the packets. Before capturing the packets. And secondly, it is like it will capture the packets. For example, let's say I just wanted to capture the like packets of only Amazon, which are going from to the Amazon and coming from the Amazon, which is like request and reply packet. So I can put a filter here, which is post Amazon.com. So this will going to capture the Wireshark will going to capture that only to capture Amazon packets. It is like we are just telling the Wireshark to please capture the packets which I am providing. Okay, which I am targeting, which is TCP or any packet. It is like filter. Same as your display filter. Display filter we apply after capturing. It is like we mainly use this in the analysis purpose. Let's say Wireshark captured all sort of packets. Let's say TCP, UDP, ARP, or etc. Any packet or packets of every IP which are coming to and from my interface. So now let's say I just wanted to just check out or just wanted to display the ARP packets. So I can apply a filter, which is a display filter ARP. So this is my display filter that I just wanted to check the ARP packets only. So I just wanted to display the ARP packets. So Wireshark will going to show me the ARP packets now. Okay, the list of all the ARP packets. So that is display filter. Display filter we use after capturing the packets, and it is mainly for the analysis purpose. Capture filters we use before capturing the packets, before starting the capturing, and it is for applying the filter. And I'm telling my Wireshark to capture only the packets of this particular condition, whichever I am providing. It can be TCP, it can be any host, it can be any IP address, it can be anything. So that is like the main difference in capture filters and display filters. So where we can apply the this display filter. So this is where we can apply the display filter. Okay. For the analysis purpose. We can bookmark filter. We can also check out the recent filter. We can also add filter as a button. So these are the buttons here. Let's say you are using any filter which is a very large, like a very long filter. So we can also bookmark or we can add filter as a button so that we can avoid typing it again and again. So that is like we are just adding filter automatically. So we can also add filter as a button. We can also bookmark filters. We can also check out the recent filters. Okay, so we can bookmark, we can apply filter, we can clear the filter, we can apply, or we can press enter. We can check out the recent filters. We can add button as a filter. Okay, so these are the filter. Then we have this packet list where we will find the list of all the packets. In the packet list, we have some common types of columns. Okay, so these are the columns. So for now, let me remove this packet files. So here we have some common columns here. First column, we have this number column. Okay, number column is not, we can say it is useful for us, but this is not related to the packets. For example, what I mean is, let's say we have packets like first packet is of TCP SYN, let's say. Second packet, let's say Wireshark captured some UDP packets. Third packet, let's say some UDP again. Fourth packet, let's say some ICMP, let's say request packet. Fifth packet, let's say we have TCP SYN packet. And let's say sixth packet, we have ICMP response. Let's say seventh packet, we have TCP packet. So here we can clearly see that we are having a handshake, which is TCP SYN, SYN and ACK. Okay, this is a proper handshake. But in the middle of the handshake, we have other packets, which is UDP, two packets of UDP. Then we have ICMP request packet. Then again, we have TCP SYN ACK packet. And then we have ICMP response packet. And then at last, we have TCP ACK packet. So let's say I'm requesting to any particular server and I am making my connection. I'm establishing a connection to that server. So first I will share the TCP SYN packet. Okay, so let's take a scenario. Let's say there's a delay at the server side and the server takes around some few seconds to share me or to send me the select packet. So let's say there's a delay. And within that few seconds, Wireshark captured other packets, like packets of other protocols. Like let's say UDP, it can be ICMP, it can be any packet, any packet. And then my Wireshark, which is my machine, receives the TCP SYN packet from the server side. So the number mark here is 5. So this doesn't means that they are not in sequence. They are in sequence, but Wireshark is not showing us in sequence because of Wireshark is like keep on capturing the packets. It will not wait for any packet. It will not wait for the entire handshake packets. It will not wait for the request and response packets in the sequence. So Wireshark will keep on capturing. So that is why we have this number here. Number will not, it is not for the packets. It is for the Wireshark. Wireshark will mark these number as like line by line. So this is packet number 1, this is packet number 2, and this is packet number 9. And after packet number 9, these are all UDP packets. You can say DNS packets. After DNS packet, Wireshark captured some ARP packets. Okay, like 4 packets are of ARP. Then Wireshark again continued to capture 14, which is UDP packets, which is DNS. Then again, in the middle of DNS, we have some TCP packets, sorry, ICMP packets, some again DNS packets, some ICMP again, then DNS and so on. So you can see these are all not in sequence. So Wireshark will not capture the packets in sequence. Wireshark will keep on capturing the packets and put a number on that packet. It is like a serial number. Okay, and this number is not related to the packets. For example, let's say if I filter on the basis of ICMP, let's see where this ICMP traffic. So here we can notice there's a number which is starting from 18. 18 is my first packet, then 19, then we have this 22. So now in the middle of 19 and 22, we have some other packets. Okay, like packets of some other protocol. Then we have 23. In the middle of 23 and 25, which is 26, we have some other packets. So these numbers are not in sequence, but this flow is in sequence. This whole flow is in sequence. We have this request, reply, and everything. But numbers are not in sequence. And if I remove the filter, then everything is sequence, which is numbers are in sequence, but the flow of packets are not in sequence. So remember, this number is mainly for the Wireshark, not for the packets. This is not doing anything with the packet. It is just marking packet one by one, which is coming first and marking that this is the first packet, it is the second packet, and so on. So it is like keep on marking whichever is coming first and next. Okay. After number column, we have this time column. Time column, we will leave it for now because we will discuss time in very detail later on. But we have this time column here. Then we have this source IP, destination IP, we have this protocol, and then we have this info here. Protocol used and this information. Information is like a brief information of this particular packet, like which type of packet it is and what kind of brief information it contains. If you want to see the packet, the entire details, then we can switch to the packet details here. This contains the details of each and every packet layer by layer. So this is frame layer. This contains the information of physical layer. Then Ethernet, which contains the information of data link layer like MAC addresses and type of IP. This contains the information of like network layer, which is IPv4, and the header length, everything. Okay. Then we have this transport layer, which contains the UDP information. Okay. And then we have last application layer. We will discuss each layer one by one, okay, later on. But this is packet details where we can find the details of each and every packet layer by layer. Okay. Is it clear? Any questions?
No, oh good.
Next, we have in the packet details this option, which is generated fields here. So this means, see, we have two types of information in the Wireshark. First information is which is coming and going with the packet. Okay, which is coming and going with the packet, like packet headers. Then we have second information, which is like, for example, here we can see they're like details which are inside square brackets. This information is inside square bracket. This information is inside square bracket. And this information is inside square bracket. So these information are inside square bracket and others are not inside. Okay, for example, this information, which is length. This is a simple length, which is not inside any bracket. So the information you will find inside square bracket. These information are generated by Wireshark itself. These are not the part of the packet. This length is the part of the packet. Source code, destination code is the part of the packet. But information which are inside square bracket, these are not the part of the packet, which means these are the information generated by Wireshark itself, mainly for the user, for increasing the user interface and for making for the user to easily analyze the traffic. So the information which you find inside square bracket are the information generated by Wireshark. Okay. Every information, like let's say we have some information here. This is also inside square bracket. So these are the information. These two information are Wireshark information, and these information which is not inside square bracket are coming and going with the packet. And here you can see one more information, which is blue information. This is inside square bracket and it is in blue color, it is a link here. It is a link which will redirect you to somewhere else, which is this location. So this is a link here. So you will find link also here, and you will find the information which is generated by Wireshark. Let's say we have
So
ICMP
how
packet.
useful is this information on the square bracket?
Very useful. We will
Very
discuss
useful.
that. Yeah,
Oh.
it is like useful. Now here you can see this is packet number 22. Okay. So this is packet number 22, and this says here we have this link here which says which are inside square bracket, and it is saying that response frame is in 23. So this packet is currently a request packet, and it is saying this Wireshark is flagging this packet that the response of this packet is in packet number 23. 23 is a number here. Okay, this number 23. So
Mm-hmm.
this is 22. We are on 22 packet, and 22 packet says like Wireshark is like making the connection. It is telling us that the packet which we are looking is request packet, and if you want to find the response, it is on packet number 23. So we can also double click on this particular link like here, and this will take me to packet number 23. Okay, sometimes we have a request, and later on after 100 and 100 packets, we have response. So if you want to see the response, we can simply double click on the link here. And here you can see we are on packet number 23. And it is telling us that the request of this packet is on packet number 22. So we can double click and we can move to packet number 22. So these are links here in the Wireshark. So the information which are inside square bracket is the information generated by the Wireshark. Now, what kind of information the Wireshark generated? It can be the TCP analysis information, the response times here, the IP geolocation, the checksum validation, and some other information. And then we have this links here, which will tell us that the part of this packet is in another frame, another packet. Okay. So you will find this information in the packet details. Then we have packet bytes. In the packet bytes, we find the bytes which is in the hex dump format and like hexadecimal format. Packet bytes are mainly useful. It depends on the scenario. So packet bytes are useful when we are mainly analyzing the network, the traffic, like the malicious traffic, or we are analyzing any malware. So we can use packet bytes there, which we can also see. We can also click on this option, which is packet bytes, or we can double click on it on any packet. Let's say this packet, and this will open the packet details. Okay, in a new window, and packet bytes, which is show packet bytes here, and we can show the packet bytes. So we can again hide here. So this is a new window which open when we double click on any packet. So if you want to see the packet details in a different window, so you can double click on that packet. So this is packet details, and here we have packet bytes. Same we have here, which is packet details and packet bytes. Same as we have packet diagram, so we can change packet bytes, packet diagram. We can simply click on edit, preferences, and here we have this option of layout, packet diagram. Now, instead of having packet bytes, we are having the packet diagram. So we have this packet diagram, which will show us the layer by layer details, like what this particular layer header contains. Okay. Then at last, we have the status bar. Status bar is very useful here. Now, what is the purpose of status bar? See, this is the status bar here, this bottom pane. Okay. Now, this will show us here, it will show us the name of the file. Okay, like file name here. Then here it will show total number of packets, which means we have 80 packets here. Total number of packets. Then we have this displayed packet. Okay, which means out of how many packets it is displaying. This is useful when you apply a filter here. For example, if I apply a filter, let's say ICMP. So you can see out of 80 packets here, 31 packets are displayed here, which means it filtered out the traffic. So 31 packets are of ICMP. So number of packets, which is total number of packets, and displayed packet. Then it will also show the drop packets. Now this drop packet is not useful for us. Why? because it will not going to show the actual loss. Let's say there's a packet loss due to any reason. Let's say there's a high traffic at the interface, or they're like high traffic in the network, or they're like any reason. But this drop packet will not show you the actual drop. This will show you the drop packets which is dropped by the Wireshark. Let's say Wireshark, let's say you are running the Wireshark in your machine. With the Wireshark, we have multiple services running also. Let's say multiple applications. Let's say some games or some other browsers and so on. So now there's like a high traffic in your interface. Okay, like at your interface. So in that case, Wireshark, there's a chance Wireshark can drop packets. And when the Wireshark drop packets, then we can see here that how many packets the Wireshark drop, and then the percentage of the packets, which is like drop packets. Like how many packets dropped by the Wireshark, not by any other reason. Okay, so the packets dropped by the Wireshark is not, we cannot say that that is a actual packet loss in the network. Maybe my
Okay.
machine is receiving the packets, but Wireshark is not capturing those. So it can be any reason. But that will not going to show you the actual packet loss. So this drop packet is a kind of not useful for us. Okay, it is like useful in very rare scenario. Let's say when there's a high traffic and Wireshark unable to capture the packet. Okay, then we have this drop ratio,
Mhm.
like drop numbers. Okay, but this will not show you the actual packet loss. Let's say we have a packet loss due to the server or due to
Mhm.
any other reason, then that will not go to show you. Then we have this profile option. Now profile option is important. Let's say here we have this profile, default profile. Now let's say I can create my own profile here. So I can create my profile by putting the my job role here. Let's say there's a system, and that system is used by many users. Let's say the security analyst, the network engineer, and let's say an application developer. These three persons are using the same system and the same Wireshark for capturing the packets and for analyzing. Let's say now here we can create our own profile for different users, for the security analyst, for the network engineers, and for the application developer. Now, why it is useful? Let's say I am switching to different profile here. I have the security analyst profile. So if I switch here, you will see the change in the interface. So the interface has been changed here. Okay, you can see, let me remove the filter first. You can see these are change in the interface. So Wireshark is a very powerful tool and it is a very flexible application. With the help of Wireshark, you can change the entire interface. You can keep it what you wanted to see, and you can remove whatever you don't want. Even you can change the filters, you can change colors, you can change everything in the Wireshark. It depends on your preferences, on your requirements. So let's say the network engineer changes the interface on their requirement, and the security analyst changes the interface on their requirement. So the one interface will not collide with the other interface, or we can say the one interface do not affect the other interface. That is why we have this profile here. If I switch to the profile of application developer, you will see a different interface here. Okay, you can see the colors of the UDP. The DNS here is brown color. But if I switch, even the layout is changed here. But if I switch to the security analyst, you will see green color for the UTP packets. So there's a change in colors, this change in layout here, and this change in various options. If I click on default, again there's a change in the options. Now you can see blue color. Apart from color, we can change many options here, like the layout, the like what we wanted to see, like panes, and many other options. Okay, so that is why we have this profile option. It is like useful for if we have multiple users in a single, like using a single Wireshark or a single system.
So how do we create the
Okay.
profile?
Yeah, we can create it easily. Like we can right click here
Yeah.
and we can here with this new here, new profile. And then you can name your profile. Let's say my profile name is um let's say anything. Let's say security underscore engineer. And I can put it is a personal profile and then click on OK. So now the profile switched to security engineer. Now it is a security engineer profile. And same as we can right click and we can manage the profiles.
Okay.
but there's no security here. Like any user,
Can log in.
like
Yeah.
any user can check the profile of
Change.
any other user. So there's no security here and there's no restrictions here. So any
Mhm,
user can check out or make changes in any other profile.
mhm,
But we can make profile. That is like a option here.
mhm.
Is it clear?
Yeah, got you.
So this is all about the interface of Wireshark. Okay, this one more thing. If I apply a filter here, let's say let's switch back to the profile of it. Let's say if I apply a filter here, which is ICLP. Here, when we apply a filter, you will see the filter name, which is ICMP here also at the corner. If we
Mhm,
don't apply any filter, you will see the file name. Or if we apply a filter, then you will see the filter name here, which is ICMP. Same as we can see the number of packets and how many packets are displayed over on top of the entire packets and the profile here. So if we are applying any filter, then we will see the filter name. And if we are applying no filter, then we will see the file name here. Okay, so this file is not saved. If you save this file, you will notice the file. And for saving file, we can save file in the Wireshark by using two extensions. First is pcap and second is pcap ng. So pcap is mainly for, it is like, pcap is like a default format for saving file. Then we have pcap ng. Pcap ng will save file in more detail than pcap. Now what is detail here? It is like, they're same only, but PKMG will save your file. It will store your file in a detailed format, contains more detail than the PKM. Okay, and the file size is also larger than PKM. PKMG contain the like higher size than PKM. So this is a difference, and the default format is PKM only. And rest it depends on the scenario. If file size is not a concern, then we can save in the pkmng format. And if there's a concern for the space, like less, like if there's a less memory, then we can save file in the pkm format. Okay, but always save your file in the pkmng. But there's like a slight difference, not a very high difference. Okay, is it clear this much? Any questions?
Yeah, no problem.
So
It's
this
like
is all about the, yeah.
it's pretty much like you're talking about just a general thing on the file. Oh, sorry, packet. Wireshark.
I'm sorry.
I mean, like you're just talking about the like a tool menu bar options. What we can do
Yeah, just
on
the
the
interface.
just the
Just
interfaces.
a
Oh yeah,
very brief introduction.
yeah, yeah. I got you.
Okay, just I'm telling which options are where and where we can approach and
Uh-huh.
how many options are there in the interface so that we can get familiar with the
Yeah, yeah, no.
interface.
Yeah, yeah, true.
Okay. Next, we have some theoretical part to cover, and it is again not very important, but we can check out. So we have a definition of a network analysis here. So the network analysis is a method which is mainly used for what we do in the network analysis. We mainly analyze the traffic, we capture the packet, we control, and we monitor. That is like all about network analysis. So, like, what is the purpose of the network analysis? So, when we perform any network analysis, we understand the networking details, like how we understand the structure of the network, the structure of the packets, layer by layer. Then we can also troubleshoot the network, okay, with the help of Wireshark or with the help of network analysis. We can also perform security operations in the use for detecting the security threats such as port scanning or network. Let's say if someone is scanning my network, let's say someone is scanning my like my port number, my system or anything, then I can check it out with the help of Wireshark. That someone is scanning my network or someone is gathering information about my network. Then we have learning more about network protocols at a microscopic level. So we can check out the protocols layer by layer. We can check out what protocol, what kind of features, what kind of headers it contains. Then we can also perform the VoIP analysis. So these are like some benefits of using of like a purpose, we can say, for network analysis. Then we have some troubleshooting tasks. Now these are like the checklist. You can think of a checklist for the network analyst. Like what kind of operations or what kind of task a network analyst can do with the help of network analysis or with the help of Wireshark. So here he or she can identify the problem, check for the hardware, perform a DNS check, or contact the ISP, check on the virus and malware protection, or review the logs and document the issue. So these are the tasks, like a very few troubleshooting tasks. Then as a security task, what kind of task a network analyst can perform? So he or she can monitor the network with the help of Wireshark or any other application. He or she can maintain the network security, okay, by finding the vulnerabilities, while finding the loopholes in the network and in the network devices. Then implementation of firewalls, IDS and IPS, then finding the network vulnerabilities on the regular basis, and serving as an active part of incident response. It is like taking part with the security team to find the malwares or the malicious traffic, the source of the malware, where they are coming from, like the entire investigation, so that we can prepare the report and submit to the security team.
So,
Then we
like
can
when you
also
say
provide
network,
some.
sorry, yes, sorry to disturb you. Sorry, when you say the network vulnerabilities, are you performing, like we perform this on the PC itself, or while the PC is connected to the network, or do we have to connect it to the firewall or to the switch in order to get the network vulnerabilities?
It depends on where are we finding the network vulnerabilities. Let's say we want to find that if my router is vulnerable or not. So I
Okay.
can simply attack on my router. It is not compulsory. Yeah, it is compulsory to be in the network, to be connected with the router, not physically, like just wirelessly. We can connect
Uh-huh.
and we can attack on the router, and we can check if router is vulnerable or not. If it is, then we can fix it. If not, then it is okay. Right.
Okay.
So it depends. We can check for the switch. We can attack on the switch. We can also attack on the firewalls. We can try to bypass firewalls with the help of malwares or encoding or decoding and the evading like techniques. We can try to bypass. And if we able to bypass, then there like some problem with the firewall, like there's some vulnerability or we can see some loophole on the firewall, and then we can fix it. Okay. Then we can also provide the support, the relevant stakeholder, including the auditors, consultants, and so on, so that we can just prepare some kind of report and can help the security team and the risk assessment team. We can update the technology and techniques. Okay, if there's any bug or if there's any loophole, then we can also update the devices. Then we can also responsible for planning for the security assessment and other projects. It is like some checklist or a kind of a task performed by a network engineer or a network analyst for the security team. Okay, as a security task. Then we have some optimization tasks which network analyst can perform. Like he or she can use some proper tools and techniques. Okay, for improving the flow of the network. He or she can use some sustainable techniques or strategy for maintaining the network. Okay, the availability of the network and the confidentiality and integrity of the network. And then he or she can support and provide information, management of unplanned emergency, and so on. Like he or she can also support the network engineer and risk analyst team. Then we have some application task for the network analyst. Like he or she can analyze the application, check if that application, the flow of the application is working efficiently or not, check for the protocols, check for the port numbers, check for the, if there's any problem, then he or she can document the issue. And he or she can also keeping up the advancement in application, like keep on updating applications and so on. And if there's any problem, or if that person has to like report to someone, he or she can also consult the internal departments or any other high authorities or any other staff. So these are some like not so important. Like I'm just telling about some tasks that we can perform. Okay, that particular network analyst user can perform. Okay, so these are some tasks. Then again, last we have these legal issues. Like legal issues are like Wireshark is a very powerful tool. Wireshark can capture all sort of packets, even if they are encrypted or unencrypted, both. So here Whenever we are capturing on any company or on any on to any inside any company or to any device, uh, like before capturing, it is important to read the procedures and the compliance of that company. Okay, like the standards and their guidelines, like what we can do and what we cannot do, what is out of scope, what is in scope, what we can capture, what we cannot capture, and so on. So before capturing, we can just check out the like guidelines or the some compliances of the company, and it may vary from company to company and country to country. Okay, like for example, this is an example of a legal issue in the US. Like we cannot capture simply like we can start capturing. So before that we have to sign something or maybe we have to read something or like the compliance or the procedures or the standards. Okay, is it clear this much?
Yeah, it's fine.
Okay,
Are we
so
looking? Do are we will we I mean like will are we looking on this network thing like network analysis?
yeah, we
Like
will
when we do the
entirely
packet
perform the
capturing?
troubleshooting. Yeah, we will
Okay, yeah,
completely perform the network analysis first, like the
yeah,
troubleshooting
yeah.
and do the packet, identify the packet loss, packet delays,
Okay,
mainly like the common problems in the
yeah,
network.
yeah,
And
yeah.
also, we will understand about protocols, like how the
Okay.
protocols are working, their
Mm-hmm,
headers, and everything, okay, which are
mm-hmm,
important for the troubleshooting.
mm-hmm.
Okay, so this is all about the interface. So, do you have Wireshark in your machine?
Yeah, I did.
Okay.
I just
So
installed it.
that's so what you can do, you can simply just go through the. I will share this recording session and I will share the this notes file. Just
Mm-hmm,
go through this particular the interface of Wireshark, get familiar, and
mm-hmm.
rest we will continue tomorrow. Okay.
Yeah, no
So
problem.
tomorrow we will discuss about the display filters and capture filters. Okay.
Display filter capture. Okay.
This one more thing. Is there any chance that you can like we can change this timing to 9 o'clock in the morning? Like this,
Nine
any
nine
slight
o'clock in the
chances?
9 o'clock in the morning.
Yeah.
9 o'clock. 9 o'clock is not possible for me. Yeah,
Okay.
yeah.
And any other
Nine,
timings like in the middle of 9 to 4?
between 9 to 4.
Like if it is possible. Otherwise, it's fine. Like if it is
Yeah,
possible. Okay, you can check
yeah.
it out your schedule. If it is
I'll,
possible,
I'll
you
I'll let
can
you know.
just
Yeah, yeah. I'll let you, because yeah, that's why I asked for 4, because I think she was saying asking me for 3. It's just I think it was a little bit difficult. Yeah, I prefer morning as well, but unfortunately I don't have time in the morning. So yeah. Mm,
okay, no issue.
yeah.
So we
Okay.
will continue at this time only. Okay.
Okay. Sure. Yeah. Sure.
So I will please share me your mail ID in the group. Okay, so that
Okay.
I can
Yeah.
share the recordings.
Okay. No problem. I'll do.
Okay, thank you. And rest
Okay.
we will continue tomorrow.
Okay. Thank you.
So in this session, we will start with the display filters and capture filters.
Okay. Sure.
So we have this capture filters and display filters. So what is the difference is in the capture filters we use before capturing the packets. Let's say I just wanted to capture the packets of specific protocol or any specific IP address or any port number or etc. So I use capture filter. So which means I'm telling my Wireshark that please capture only that particular packet. Let's say I just wanted to capture the ARP traffic. So I'm just telling my Wireshark that please capture the ARP traffic. So that is a capture filter. So we use capture filter before applying it, before capturing. Okay, so it is like we first we decide the capture filter and then we start the capture. So now capture filter follows a specific syntax, same as display filter. They follow a same syntax. Capture filters are like we are applying before capturing, so they are like very limited in number. But we have very like large number of display filters. So now what are display filters? It is like we apply after capturing, which is whenever we are analyzing any file, then we apply display filters. So display filters are like, let's say, Wireshark capture all sort of packets, ERP, DNS, TCP, any like all sort of packets. So now let's say I just wanted to analyze the Amazon traffic, or let's say any traffic of any other protocol, let's say any TCP traffic or any port number traffic. So in that case, I will apply the display filter. So display filter after capturing and capture filter before capturing. And display filter is mainly for analysis purpose, and capture filter is mainly for the capturing purpose. That is like the main difference. Then we have very limited number of capture filters, and where we apply capture filter. So here we can apply the capture filter. Now we have like few kinds of capture filter on the basis of scenario. So first, let's say I just wanted to apply capture filter on the basis of protocol. So I can simply mention the name of the protocol, let's say ARP, DNS, TCP, or any other protocol. So for applying the capture filter on the basis of protocol, I can use the protocol name. And let's say I just wanted to capture on a specific port. So here I can use port, and that port number I wanted to capture. Now, if I am applying port number 1224, so it will going to capture the packets on port number 1224, whether it is coming or going. Same as port number 80 or 53. If I wanted to capture on any specific IP address, so I can put here host and the IP address I just wanted to capture. So here I'm telling the Wireshark that capture the packets of this IP address only. And the Wireshark will ignore any other packet and just capture the packet of this specific IP. Same as I can put a domain name as well. Let's say Wireshark.org. So we can also capture by specifying the IP address or the domain name. Same as we can also put TCP port HTTP or TCP port SMTP, or we can put UDP port DNS. So here I am specifying that capture the HTTP traffic which is under TCP. So this will going to capture the TCP as well as HTTP traffic. Okay, here I'm just specifying HTTP traffic. So here this will just capture the HTTP traffic. For example, let's say whenever we are capturing on the HTTP traffic, the Wireshark first make the connection, which is TCP SYN, like some handshake packets. So whenever we are specifying TCP port HTTP, so in this scenario, the Wireshark capture the handshake packets also, as well as HTTP packets also. But whenever we specify simply HTTP, so this will only going to capture the HTTP traffic and ignore the TCP handshake packets or any ACK packet. Okay, like any acknowledgement packet. So here, whenever we are specifying TCP port HTTP, so this will going to capture the HTTP packet and also the TCP packet used by HTTP. Okay, same as with this scenario and same as with the DNS. Then we have this one, which is not multicast. So these are like we want to capture. Let's say I just wanted to capture the packets of every protocol apart from ERP. So here I can put not ERP. So this will capture the packets of every protocol apart from ERP, which is not ERP. Same as we can put not before whatever the filter is, and that the Wireshark will ignore that particular packet. So here not host this one. So I'm just capturing the packets of every scenario, every IP address apart from this particular IP address. Same as we can also avoid the multicast and broadcast packets by putting not multicast and not broadcast. Same as we can combine the filters. We can combine with the help of AND operator here. So here I'm just saying that just avoid the ERP packet and avoid the DNS packet together. So this will, the Wireshark will going to capture the packets of every protocol apart from ERP and DNS. Same as we can combine with multiple scenarios, like we can put not ERP and host this one, and let's say not DNS, let's say. So here I'm just capturing the packets of this particular IP address, avoiding the DNS and ERP, which means Wireshark capture the packets first of this IP address and of the protocol apart from DNS and ERP, which means let's say there's a HTTP. using this particular IP. Okay, like IP. And here we have this HTTP traffic, we have this TCP and any kind of traffic. So we are taking every traffic apart from ARP and DNS, which is using this particular IP address. Okay, same as we can combine like multiple conditions together with the help of AND operator. Okay, so in the Wireshark, we can capture on the multiple interfaces that we can capture on two or one or more interfaces. But in the Wireshark, we cannot apply different filters to different interfaces. For example, let's take an example first of the capture filter. Now, let's say I just wanted to capture the packets of ICMP only. So I will put here ICMP. Okay. And here you can see this bar becomes green in color, which means the filter we have applied is correct. It is of correct syntax. If I remove something, let's say P, now this becomes red in color, which is the syntax we are applying is wrong. Okay, so always mention, like make sure of the syntax. So we have this ICMP, and then we can start capturing the packet on this one. Okay, now here you can notice we have this capturing from the interface name here, and then brackets ICMP, which means we are capturing on the interface ETS0, and we have applied a filter which is ICMP, and it is a capture filter. And here you can see we have no packets because Wireshark is not capturing any sort of packets apart from apart from ICMP. So now what we can do, we can generate some packets of ICMP, and we can see this example. Let's say ping google.com. Okay, and here we have the packets. So these are all ICMP packets. Okay, so Wireshark will now going to capture just the ICMP traffic. Same as, let's say, let's restart the Wireshark. Now let's say we have multiple filters here. Sorry, multiple interfaces here. We have first interface, we have second interface, and we have third interface. So now Wireshark can capture the packets on multiple interfaces, but Wireshark cannot apply the multiple filters on multiple interfaces. For example, let's say I just wanted to apply the filter like ICMP on the first interface. On the second interface, I want to apply ARP filter. And on the third interface, I want to apply a different capture filter. That we cannot do in the Wireshark. In the Wireshark, we can only apply one filter at a time to every interface here. But we can do this in the T-Shark. That is a CLI version of Wireshark. So in the T-Shark, we can capture on the multiple interfaces as well as we can apply multiple capture filter to different interfaces. That we can do. Okay, but in the Wireshark, we can apply one filter at a time. Is it clear? The capture filters?
Yes, ma'am. So in TSAC we can apply on multiple interfaces, isn't it?
Yeah. In the T-Shark, we can capture on the multiple interfaces as well as we can apply different capture filters to different interfaces. But in the Wireshark, we can capture on the multiple interfaces, that is possible, but we cannot apply different filters to different interfaces. Okay. For example, let's say in the T-Shark, what we can do, let's say I'm capturing on two interfaces in the T-Shark. So in the first interface, I can apply a filter, let's say capture filter, not ARP. And in the second interface, I can apply a filter host, this one. So in the first interface, I am saying that I just wanted to capture the packets of every protocol apart from ARP in the first interface. And in the second interface, I'm saying that just capture the packets of this particular domain. So this is like how we can apply different like capture filters in different interfaces. Okay, that we will see in the T-Shark, but this is only possible in the T-Shark, not in the Wireshark.
Okay.
In the Wireshark, we can just apply one filter at a time. Okay, same as you can use any of the filter given here. You can see these filters here also in the Wireshark capture, and these are capture filters. So here we have different filters. First, we have this filter, which is on the basis of physical address. Then second is of ARP. Third is of not multicast and broadcast packet. And then fourth is of not ARP, which means we are capturing packets apart from ARP traffic. Then we have IPv4. Then here we have this host, IPv6. Then we have again this host, which is IPv6 IP. Then we have this TCP, UDP, and not port number 53, which is we just don't want to capture the packet of DNS. And then port 80 and so on. And then we can combine the multiple filters with the help of AND operator here, which is not port number 80, not port number 25, and capture the packets of which is coming on this particular domain. Okay, we can create our own filter here and we can remove any of the filter. Let's say I just wanted to add my own filter here. So I can click on this plus option. And here I can mention the name. Let's say HTTPS. So here I can put here not HTTPS. Okay, sorry, HTTP 2. So in the Wireshark, we have HTTP 2 for the HTTPS. Okay, so or we can also mention here not port number 443. Okay, so this will not going to capture the packets of HTTPS. Same as we can remove filter, we can click on this minus option to remove the filter. So we can add our filters and we can remove it. Okay, so this is like how we can use capture filters, and capture filters are limited in numbers. It depends. So you can create your own capture filters, but follow the syntax. Is it clear this much? The capture filters?
Yes, ma'am. So the one you showed me, these are by default, yeah, in the WhatsApp.
Sorry?
The capture filter that you showed me just now.
Yeah, those are default.
Those are default. So we can add our own as we go on.
Yes.
Okay.
Then we can discuss the display filters. So in the display filters, let's say Wireshark captured all types of packets. So we wanted to filter on the basis of specific condition, then we can use display filters. So again, let's say we wanted to apply the filter on the basis of protocol. Then we can simply use the protocol name here. Same as here we have this TCP.port number 80. So let's say I just wanted to filter the HTTP packet. So we can apply this TCP.port number 80 or TCP.port number 443 or any other port number. Same as we can use UDP.port number 53 DNS, or we can use any port number here. Same as if I wanted to apply the filter on the basis of IP address. So I can put IP.addr and then IP address I just wanted to filter. Okay, so let's see. This is an example. So here we have this file. In this file, we have many packets. Okay, so for now, I'm just making a change. Let's say we have this IP. So this is source IP and this is destination IP. Now let's say I just wanted to filter on the basis of, let's say TCP port number. So I can put TCP here as a filter here. So now here you can notice in the status bar, we have like around 1,229 packets, 1229 packets, out of which 67 packets are displayed here, which is 67 packets are of TCP only. Okay, rest are of UDP. Same as let's say I just wanted to apply the filter on this particular IP address, 170.114.108.142. So I can put here IP.addr equal and then IP address. So let's say 170.114.108.143. Enter. Okay, now you can see out of 1,229 packets, we have 1,222 packets are of this IP only, which is, this is like a Zoom IP. Okay, so we have around many packets are belongs to this particular IP address, either on the source side or on the destination side. So this IP can be on any side, either on the source or on the destination side. If I apply here in place of ADDR, I can put source here, which is SRC. So you will notice this particular IP, which is 170 on the source side. Okay, on the source side, you can see we have same IP on the source address. Same as we can put the DST in place of source. So now this IP is on the destination side here. Okay. So this IP is on the destination side. If I scroll down, you will see the same IP on the destination side, the same IP. So we can put IP.addf, which is address, and then we can put IP.src for source and IP.destination for the destination IP address. Same as we can use this port number, which is, let's say, let's open any other file, any different. So in this file, I have around 47,000 packets. Okay. 47,000 packets. So let's say I just wanted to filter on the basis of TCP dot port number equal 80. Okay. Now here you can see we have applied. Here you can see we have applied this filter. So this filter will show us the TCP packet as well as the HTTP packet. Okay. So it will show me the HTTP packet first and then TCP handshake packets also, which is established on top of HTTP. So we have this CCNA and F packet, and then we have this some login, some HTTP packets here. You can see. So these are TCP packets, but of the HTTP only, of the websites only. Same as we have this HTTP packets. And if I scroll down, same as you can see, all these TCP plus HTTPS traffic. Sorry, HTTP traffic. Same as I can put here 443 for the HTTPS traffic. Okay. So this is all HTTPS traffic. But if you see the HTTPS traffic in your machine, then you cannot, because first we have to decrypt the HTTPS traffic, then only we can see. Okay. So we will see how we can decrypt the HTTPS traffic in the later sessions. So here, if I apply simple port number 80, so this is for the HTTP plus TCP. If I remove this entire filter and if I just apply HTTP, so this will only going to show me the HTTP traffic, not TCP. Simply the HTTP packets. Okay, there's no TCP packets, no handshake packets of these websites. But if I put here TCP dot port number 80, so this will going to show me the handshake packets as well and the website packets, which is HTTP packets, both. Okay, same as we can put for the UDP, we can use UDP dot port number equal 53 for the DNS. So we have around 373 packets, which is of DNS working under UDP. Same as we can put here source port. Okay, we can put here source port. So now UDP port number 53 comes on the source side. If I apply a filter here as a column here, so here you can see the source port. So it's here. Can drag it here. Okay, here you can see source port is so source port is DNS only, which is 53 only on the source side. So I have put UDP dot source port equal 53. So this is on the source side. Same as we can put on the destination side. So here I can put DST, the destination port. So now you will see this one destination port. We can right click and we can apply this as a column so that we can see here, and we can drag this column after destination. Okay, so here you can see the destination port is 53. Every packet contains destination port as 53 only. 53. Because here we have used UDP.DST, which is destination port 53. Same as we can use with a TCP or with the UDP. So apart from this UDP, we can also put here source port like this. TCP.source port, or we can put here UDP.source port or any port number. Same as we can put UDP.DST port, okay, which is any port number. Same as we can do with the TCP.DST port equal any port number. Okay, same as in the display filters, we can use not sign here, not ERP. So this will show me the packets, like all packets apart from ERP. And here we can also use this sign and this not, they are same only. Okay, so if I run this file, let's see how many packets are there of ARP. So we have no packets of ARP. So what we can do, we can use not TCP. So this will show me the packets of UDP only, not TCP. Is it clear?
Yes, ma'am.
Okay. Same as in place of not, we can also use this sign, which is not TCP. They are same only. Okay, they are same only. Same as we can do, let's say I just wanted to see the traffic of every IP apart from this IP. So we can use IP.addr not equal to this particular IP. So let's see. Here we can apply this filter IP.addr not equal to this IP. Let's say this IP 192.168.0.10. So this will show me the packets of everything apart from this particular IP. So these are all multicast or broadcast packets. Okay, which is this IP is like the local IP where we are capturing. That is why all packets contain this IP. But apart from all packets, 3 packets are there which are multicast or broadcast packets. Okay, so we can use not equal sign. Same as we can use here dot one, which is we wanted to see the packets of every packet apart from address of router. Okay, like packets of the router. Same as we can put IP.addr in place of IP.addr, we can put source. IP.source not equal this IP. Same as we can use IP.destination not equal this IP. So we can also use equal sign and not equal sign. Okay, then we have this AND or OR operator. Now we can combine the filters. Okay, for example, let's say here we can click on this analyze and this display filters. In the display filters, these are the default display filters. Okay, just like we have capture filters. So these are the default display filters. So here, first filter is of like we can apply on the basis of MAC address, again on the basis of ARP, then on the basis of broadcast, not ARP, IP, IPv4, not IPv4, IPv6, and so on. Okay, they are same only. Then we can combine the filters with the help of AND or OR operator. So we have AND operator and OR operator. So what is the difference in AND or OR? Let's say we have 2 conditions here. So whenever we are using AND, we are applying more than one condition. Okay, that is why we are using AND. We wanted to combine the condition or we wanted to combine the filters. So let's say first we have this 4. It is a very simple example. So let's say where this 4 is greater than 5 and 6 is greater than 5. Here 4 is not greater than 5. Okay. Yeah, this example 4 is not greater than 5, but 6 is greater than 5. But still we have the answer is false because and checks for 2 conditions, both condition, this condition and this condition both. If one condition is false, so the answer will be false. Same as if both conditions are true. For example, here, this condition is true now and this condition is also true. So answer will be true here. But if we have this here, now this condition becomes false and this condition is true. So answer will be false here. So AND checks for both condition, the left condition and the right condition. This is AND. Then we have OR. In the OR checks for one condition. If one condition is correct, then answer will be correct. So here, let's say this condition is false, but this condition is true here. So answer is true. Now, why I'm telling this? We are going to use this same logic in the filters. Let's say this is my filter. Now here I'm saying that in place of ARP, I can use this one. Let's say I'm saying here that I just wanted to like analyze, or I just wanted to apply the filter, which will show me this IP first, and then the port number working on this 53, which is I just want the IP address and this port together. So Wireshark will show me the IP address which is working, which is using port number 53. Okay, so this condition both needs to be true. Then only we will have the result. For example, if I use this IP 102, so this will show me, let me change the filter, IP dot address equal and this IP. So this will going to show me the packets of this IP containing this IP, which is 192.168.0.102. Now, on top of this IP, I just wanted to see the DNS packets, which is working under UDP, not TCP. So I can put here and UDP dot port number equal 53. Okay, now you will see this particular filter will show me the IP address first of this particular IP and then working on top of this particular DNS port. Okay, so this is port DNS. Doesn't matter it is on the source side or on the destination side. We will see any side, but we will see the port number 53 either side. Okay, here we have this port number 53, then here we have this port number 53, and then here and then here. And then here we have this IP address, which is 102. Okay, same IP here. So here we applied, and you can see we have 373 packets. 373 packets, which is of this IP working on top of UTP port number 53, which is DNS. Let's say I just wanted to filter the TCP packets, TCP DNS packets. So I can put here TCP dot port number equal 53. So we don't have any packets which is DNS and working under TCP. But what if I combine this filter with the TCP? Sorry, with the IP address. Let's say I have this IP dot address equal 192.168.0.102. So this will show me all the packets. Now I can combine this filter with the filter of and TCP dot port number equal 53. Now Wireshark will show me nothing here. Why? Because we are saying that I just wanted to see the IP address of this, the packets of this IP plus working on the port number TCP 53. And we don't have any packet. We don't have any such packet. So this is my entire condition here now. This is my one condition. Okay, I'm saying that I just want the packet of this IP plus this IP will be working on top of 53 port number and that 53 is under TCP, should be under TCP. But we don't have any condition here because we don't have any port, any packet which is working under TCP. Okay, we don't have any DNS packet which is working under TCP. So that is why this condition is false. The second condition becomes false. And if one condition is false, the entire condition becomes false, which means Wireshark will show me nothing here. Is it clear, the logic of AND?
Yes. Yes, ma'am.
Okay. Same as we can use OR here. Now what OR will do? OR will just show me everything here. If I put OR here, now here Wireshark will show me the packets of 192.168.0.102 because first condition is true here. Okay, this condition is right. This condition is true because we have packets which contain this IP address 192.168.0.102. But we don't have any packet of this particular condition. But here we are using OR operator. OR will check for one condition only. If one condition is true, then we have the answer here. If I put here, let's say UDP dot port number 53. So this will going to show me packets of every IP address which is working under 53 port number. And secondly, packets of every protocol which is using this particular IP address, which means everything. Okay, so now here you can see we have around 47175 packets, like almost every packet. Okay, like we have almost every packets. Why? Because we are using OR condition here. This condition is true and this condition is also true. So Wireshark first filter out the packets which contain the DNS, okay, like DNS port, and working on any IP, no matter this IP, working on any IP. Then we have this IP, Wireshark will take this IP and show me the packet of every protocol. Doesn't matter it is a DNS or not, show me the packet of every protocol and which is working on this IP. So that is why we have this much number of packets. But if I use here AND, so you will see just 373 packets, just few packets. Okay, you can see 373 packets. which means here we are combine first condition and second condition together. Okay, so that is why we have this AND or operator, and it depends on the scenario whenever we wanted to use AND, which means we are checking for two conditions, and when we use OR, which means we are checking for one condition. Okay, in place of AND or, we can also use pipeline for the OR and ampersand for the AND. Okay, like here we are using AND here. In place of AND, we can use double ampersand. So this is also right. Same as in place of OR, we can use double pipeline. Okay, double pipe. So this is OR. So this was is also same. So either we can use OR or we can use double pipeline, or we can use AND, or we can use this ampersand. Okay, like they're like symbols. Okay, is it clear?
Yes, ma'am.
Now, tell me what this packet means, this filter means. Like, will Wireshark show me something or not?
Ampersand 53 TC dot.
You are not audible.
Am I audible?
Yeah.
Hello?
Now you're on. Yeah.
Okay. Both the condition has to be true.
Yes. So both condition needs to be true. So will Wireshark show me something or not in this condition if I apply on my file, on this file? So if I click on enter, Wireshark will show me nothing here because we have packets of DNS which is working under UDP, but we don't have any packets of DNS which is working under TCP. Yeah. So that is why we don't have anything here. But if I put here OR, then the Wireshark will show me the UDP packets, which is working under TCP, sorry, UDP.
UDP.
So these are all DNS packets working under UDP. Then, apart from, okay, one more condition, this one. Now, this condition says that we have this IP address. So always, whenever we have this large condition, read from right to left. So first, take this condition from the parenthesis, which is inside parenthesis. So here this condition says that first here we have this port number and second we have this port number. Now now here we are using OR here. So if I apply this one, Wireshark will show me the packets of UDP, okay, which is working under DNS, like DNS packets working under UDP. Because here I'm using OR here. Then I am combining this particular filter with the AND here. So AND means Wireshark will show me the packets of DNS working under this particular IP. Okay, so I can just copy this entire filter and here we can apply. So again, we will see 373 packets only. Okay, so here, sorry, 189 packets, 189. Because here I have used source here, IP.source, because this IP is on the source side. If I put here IP.address, so we will see 373 packets again. Okay, so here we have this 373 packets. Now here, first we will take this condition, this much. Here, one condition is true and one condition is false. So we will remove this condition and we will take this condition because we are using OR operator here. Then we will combine this condition which is remaining with the other condition with the help of AND operator. Okay, which means this condition makes up to here. Okay, leaving TCP. So here we have this one, which is we are saying that we want the packets of IP address this much, which is on DNS only. The packets should be of DNS working under UDP.
So when you put that IP.source, so what's the difference like IP.source and IP.address? Like IP address is like particular, like when you say IP address equals to, that means that IP address equals to 0.102. But when you say IP.source, that means the source is containing the same IP address, isn't it? 0.2.
When I put IP.address, so here you can see this IP, which is 192.168.0.102, either on the source side or on the destination side, any of this side. So here you can see in the source side, then we have this in the destination side, then we have the source side and then destination side. But we will have any of the side, like we have this IP in any of the side, either source or destination. That is address.
Okay.
But if I put here source, Then you will see this IP only on the source side,
On the source side.
only on
Okay,
the
gotcha.
source side. So here you can see just one single IP address, the same IP here, and the same IP here. Doesn't matter, but we have the source here, this IP. Same as if I put here in the destination, you will see this IP on the DST side, which is destination state, which is 192.168.0.102 at this side, the same IP, which means we are receiving the packets from the router. Okay. This is all reply packets from the router, coming from the router. Okay, because obviously we are on the destination side, which means we are receiving, we are on the receiving end,
Yep.
and source is on the sending. Same
Source.
as if I put source here, which means we are requesting. Okay, this is we are all requesting. These are all request packets. We are requesting to the router here. Okay. So that is the difference. But if I put here simply address, this means we are checking the request as well as reply packets both. Okay, both sides. Then apart from this logical operator, these are known as logical operators, and or. Then we have comparison operators. So comparison is like we can compare, or we can we can use some kind of like expressions here. For example, here we have this greater than, less than, greater than equal to, less than equal to, then not equal, and double equal, which is equal. So let's say I just wanted to check out the packets of HTTP which contains response code 200, which means the web page has been loaded successfully. If we have 200 here, so here let's apply this filter. We have this HTTP dot response code equal 200. So we can see how many packets are of 200 containing the 200 response code. So here you can see these packets contain 200 response code. 200, okay, this one, which means these web pages has loaded successfully. Then we have, let's say, I just wanted to check the response code greater than 200. Okay, just greater than 200. So this will show me 200, like greater than 200, which is 201, 202, and so on. So we have two packets which contain response code more than 200, which is 404, which is not found, and 302 found. Now when we put simply greater than, which means 200 is not included here. But if I put here 200, like greater than and equal to, which means 200 is included here. So if I remove this one, which is we are starting from 201, 202, 203, and so on. But if I put here equal sign, which means we are starting from 200, 201, 202, and so on. So here, which means 200 is included here. But if I remove this equal sign, 200 is excluded here. Okay. So let's say I just wanted to see the packets which contain the response code like more than and equal to 200. Then you will see we have 4 packets. Okay, 4 packets containing the code 200 first, and then 400 and 302. Okay, so this is like included. 200 is included here. Same as we can do with the less than. Okay, we can do here less than and equal to, which is 200 is again included here. Okay, so again we have 2 packets here of 200 only. If I remove here equal sign, then we are not including 200, which is we are starting from 199, 198, 197, so on. So we don't have any such packet which contain the response for less than 200. Okay, same as, now tell me, what is the meaning of this filter? This particular filter.
Code 200 and rest. So it will stv.response.code greater than 200. It will display packets greater than 200 and stv response. Okay. So yeah, it'll display the packet which is greater than 200 and less than and greater than 200 and less than equals to 300. So anything packet
exactly.
between 201 and 201 and 300, it'll display the packets.
Exactly. So it is like in the middle of 200 and
Yeah,
30, 300.
300. Yeah.
Sorry, 201 and 30.
Two-
So this will show with the show the packet which is in the middle of 200 and 300. Okay, where 200 is excluded. If I put here equal sign, which means 200 is included here.
Included. Yeah.
So this is how we can use comparison operator. Same operator you can see here in the analyze, display, filter expressions. Same filters, like same expressions here. So these are like relation, like expressions, which is like equal, not equal, and so on. Contains and matches and so on. Okay. So this is how we can like apply filters. Now we can also bookmark filter. Let's say I have this filter and it is a very long filter. So let's
Yeah.
say here, this is a very long filter. So now I can bookmark this filter so that I can use it frequently, okay, without typing it. So I can click on this blue sign here, this blue bookmark,
Mm.
and click on here and this save this filter. Once I click on this save this filter, here you can name your filter. At last, you can name your filter. So let's say my filter is important underscore filter. So this is my important filter and I can click on OK. Now you can see this yellow sign, means this blue sign turns to yellow color, which means this particular filter has been bookmarked. Now we can simply check it out. We can click on this yellow sign and this is an important filter. So if I remove this filter from here and if I click on this bookmark and here we have this important filter. So if I click on this one, you can see the filter has been automatically applied. So this is how we can bookmark. Even we can add filter as a button. Let's say I just wanted to use this filter as a button. So I can click on this plus option and I can click on plus. Let's say this is again a very important underscore filter. Okay, very underscore important underscore filter. And I can click on OK here. Now you can see these are all the buttons here. These are all buttons. And this is my button which containing very important filter. So what I can do, I can simply remove this and I can add this one, which is I can click on this very important filter and the filter has been automatically applied. So either we can add filter as a button or we can add filter to the filter list. Means we are adding the filter here. Here you can see this is my important filter. So when you bookmark your filter, you will see a bookmark filter here. And when you add a filter as a button, you will see a filter here. So you can do both ways. It depends on the scenario. Okay, if you have any large filter, then you can simply add your filter as a button. Okay, same as you can see the recent filter from here. It is like a small upper arrow, sorry, down arrow. These are all my recent filters. Okay, and we can clear the filter. We can use this cross option to clear the filter. Okay, so this is how we can bookmark, we can add button, and we can clear the filter. And we can see the recent filters. Okay, I hope this much is clear. Now we can move to this one, which is then we have these three ways of applying display filters. So the filters we were applying is like we are creating by ourselves. It is like we are creating manually. Okay. Like we are creating manually. So what we can do, we have a few options of creating the filters. First filter is we can create our own filter. Okay, which we were doing here. Second is we can take filters from the internet or from the cheat sheet. So what I will do, I will share a cheat sheet after the class so that I can share the most common filter to be used so that you can use the filters from there as well. And third option is we can take filters from the packet details. This is very important. So first two options are manual again. We can create our own filter or we can take filter from the copy the filter from the internet or from the cheat sheet and we can paste there. And third option is we can take filter from the packet list. This is more like an automatic way. So what we can do, we have this packet list here and then we have this packet details. Now let's say I just wanted to apply the filter on the basis of packet details. So what I can do, let's say I just wanted to apply, you can pick up any detail from here, any detail. Let's say I just wanted to apply the filter on the basis of sequence number. So I can right click here and there's an option of apply as filter and I can click on select it. Once I click on selected, you will see the filter has been applied here. And these are the packets containing CPS number 1. Same as I can pick up any detail, whether it is a Wireshark detail or a packet detail. I can pick up any detail. Let's say I can pick up detail of this one, which is TCP segment length. I can right click here, apply as filter and select it. So now this filter has been applied. And these packets containing the TCP segment length 1440. So we can pick up any detail, like any kind of detail from the packet detail, and we can apply it. Okay, whenever we are applying detail, we have multiple options. Let's say we can right click here, apply as filter. We have selected, which is equal sign. If I click on not selected, which is not equal sign, which is Wireshark will show me the packet of every packet apart from this particular filter, which is not selected here. So if I click on not selected, you will notice a small sign before not selected. Okay, this one. So this is like not selected sign. Okay, so here we have this selected and not selected. Okay, selected and not selected. Same we have this and selected, which is we are combining filter with the pre-existing filter. If I click on and selected, you will notice here we have this single filter. Now this filter will be combined with other filter. Let's say source code. I can right click here, apply as filter and selected. So you will notice here we have this and this one. This is automatically added here with the help of apply as filter. Same as we have this or selected. Okay, again same. With this or selected, it will keep on adding in the pre-existing filter. Then and not selected or not selected. They're same only. Okay, so this is applies filter. Then we have prepare as filter. Now what is prepare and what is apply? In the apply filter, we are simply applying the filter. Like we are automatically applying the filter. In the prepare filter, when I click on select it will simply prepare the filter. Okay, if I click on select, you can see it is preparing, not applying it. Here we have this filter. Now I have to press an enter key to apply it. Okay, if I press enter key, then it is applied. So in the apply filter, it is automatically applied. But if I click on prepare filter, this will simply prepare the filter, like put the filter on the filter bar. Then I have to manually press enter, then it is applied. Okay, same as others. Not selected, selected, and selected, or selected, and so on. But prepare as filter is we have to press enter key before applying. Apply as filter will automatically press enter. So why do we have prepare filter? It is like if you wanted to make any changes, if you wanted to add something, if you wanted to remove something, that is why we have prepare filter. If you wanted to apply filter as it is, then you can use apply as filter. Okay. So here we can pick up any detail, right click, apply as filter, select. Okay. Is it clear? The difference?
Yep.
Okay, so we can take any detail from the filter, from the packet details, and we can apply that as a filter, or we can prepare as a filter. We can combine with the help of and or operator. Then we have another thing which is very efficient, like very wonderful in the Wireshark. I personally found this wonderful, which is apply filter from the conversations. So what we can do, let's say my machine, which is Kali, this machine is communicating with the Facebook, and the same machine, which is my machine, is also communicating with the Amazon. So here I am sending the packets to Facebook and Amazon also, both. Now I just wanted to filter the packets of Amazon and my machine, both. Okay, I just wanted to see the packets between my machine and the Amazon. Okay, so here we can use conversation filter. Okay, like a communication filter. We can commute, like we can apply the filter, which is on a particular source and destination. For example, let me remove this filter. Let's say we have this TCP here. Okay, so let's say we have this IP address, which is 44.228.2493. So let's say this IP is of any particular domain. Let's say Amazon. Okay, let's take an example. So we can right click. We can click on this conversation filter and this TCP here. Click on this TCP. Now you will going to see the packets which is coming and going between these source and destination. And it is in sequence order. This is first packet, second packet, third packet, so on. Okay, if I show you the communication here, you will notice This is the first packet sent by my machine to this particular destination. It is a SYN packet, then SYN packet, and then egg packet, and then we have this other packets. So it is like a proper communication between this machine and this machine on the proper port number. Even the port number is same here. Okay. So let's assume here that my machine and Kali, which is Kali, and Amazon is again communicating. But this time this machine is using port number 124, and here the machine is using port number 1234. Now this communication and this communication are different. Okay, if you apply the filter, so this communication and this one are different here because we are using the different port numbers. So this particular communication is on the same IP address, same destination, and same port number. If you notice the entire conversation, you will notice the same port number, which is 52050. The same port number in every packet. Okay. But if we have another communication, let's say another window is open in the browser and we are making connection, we are sending the request, and that port number is 1234. So that is like a different communication. So this one is different, this one is different, and this one is different. So we can apply on the basis of convolutions. It is like very helpful whenever you are analyzing the endpoints. Okay. Is it clear?
Yes.
Okay. So we have 4 ways of applying the filter, which is our display filter. We can take from the internet. We can create our own filters. We can take filters from the packet details, and we can apply filters from the convolutions. Okay. There's one more option here. From the packet details, we can add